In this video, we're just going to go over all those problems from the online homework assignment, the practice problems for the test. Okay, the first problem is this. We have this equation, f of x is equal to x plus 3 over x minus 8. And the problem's telling us determine whether this function is one-to-one and then find a formula for its inverse. So for these type of problems, just whatever, if it asks you is the function one-to-one, the answer is just going to be yes. So yes, it is one-to-one. So now what we need to do is find the inverse. So remember, that's f inverse of x. And so the technique for doing that so we take our original problem, and whenever we see an f of x, we replace that with a y. So we're going to have y is equal to x plus 3 over x minus 8. And then the next step is we replace the y's with x's and the x's with y's. So we're going to turn this y into an x and then these x's into a y's. So we're going to have x is equal to y plus 3 over y minus 8. And now the goal is to solve for y. And then once we solve for y, that y is going to be our f inverse of x. So the first step in solving this problem for y is we're going to get rid of the fraction. So multiply this y minus 8 onto both sides. Or another way of saying that is just multiply the entire problem by y minus 8. So when we distribute this y minus 8 to the left, it's going to cancel with this y minus 8 on the bottom, and so on the right hand side we're just going to have the y plus 3. But when we distribute this y minus 8 to the left hand side, we're going to have x times y minus 8. So x, y minus 8. And now the next thing to do to solve for y is we're going to take this x and distribute. So we're going to have x times y, which is xy, x times 8, which is minus 8x, equals y plus 3. And now what we need to do is get the y's on the same side, x's on the other side. So what we could do is add this minus 8x over to the right. So we're going to add 8x, and then we can move this y over to the left. So subtract y, subtract y. And what we end up getting after doing that is, well, these 8x's are going to cancel. So we'll have xy minus y equals, these y's are going to cancel, so we'll have just 3 plus 8x. And continuing up here, let's just rewrite that. xy minus y is equal to 3 plus 8x. And now the last thing, or the next thing we have to do to solve for y is, well, we have a y here and a y here, so we could factor it out. Y, x minus 1, 3 plus 8x. And so now once we factor out the y from this piece, we have, the y times this, we can divide this x minus 1 over to the right. And we end up getting y is equal to 3 plus 8x over x minus 1. And like we said a second ago, whenever we, after we do the step where we replace the x's with the y's and the y's with the x's, and we solve for the y, so solving for this y right here is going to be our f inverse. So this is equal to f inverse of x. Okay, and so that takes care of the first problem. So the second problem, which is pretty much the same thing, just adds one extra step. So we're given this equation, f of x is equal to x plus 5 over x minus 6. And now what we want to do is find f inverse of x. And then we also want to find the domain and range of both f of x and f inverse of x. So let's just start by finding what f inverse of x is. So just like the last problem, we're going to replace this f of x with a y. So we'll have y is equal to x plus 5 over x minus 6. And then once we do that, we replace the x's with the y's and the y's with the x's. So we're going to have x is equal to y plus 5 over y minus 6. So we turn this y into an x, and we turn these x's into y's. So now we need to solve for y. And just like in the last problem, the first step is going to be to get rid of all the fractions. So multiply this whole problem by y minus 6. So we're going to take everything and multiply it by y minus 6. And when it goes to the right, these y minus 6's cancel. So on the right-hand side, we're just going to have the y plus 5. And when it goes to the left, we're going to have x times y minus 6. Now what we can do is distribute this x. So we're going to have xy minus 6x is equal to y plus 5. And then now we need to get the y's on the same side, and there's everything else on the other side. So we're going to take this 6x and move it over to the right. And then we're going to take this y and move it over to the left. So on the right, the left-hand side, these 6's, the 6x's cancel, and we have xy minus y. On the right, the y's cancel, and we're going to have 5 plus 6x. So now there's a y here and a y here, so we could factor it out. Take out the y, and we're left with x minus 1. And then we have 5 plus 6x. And the last step is solve for y, so divide by the x minus 1s. We're going to get y is equal to 5 plus 6x over x minus 1. And just like before, when we solve for this y is f inverse of x. So now let's work on finding so the domain and range of both f and f inverse. And in order to do this problem, we have to use this relationship that the domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. And so when we were doing these problems back in this section, we said that finding the range of either finding the range of f or finding the range of f inverse is not really possible. Well, it is possible, but it's much harder to do than finding the domain. So if we want to find both the range and domain of f, so we want to find the domain of f and the range of f. So to find the domain of f, that's easy, we can do that. But instead of finding the range of f, we're going to find the domain of f inverse. So the domain of f inverse is the same thing as the range of f. So really for this whole problem, all we need to do is find the domain of f and the domain of f inverse. And that's going to give us everything that we need. So let's just start with the domain of f. Well, f of x is this piece up here, x plus 5 over x minus 6. So when we're finding the domain, remember we have to look for square roots and fractions. So there's no square roots in here, so that's not a big deal, but there is a fraction. And the bottom of our fraction can never equal 0. So the bottom of our fraction, x minus 6, this can't equal 0. And this tells us that x is not allowed to be 6. So then our domain, if we go into a number line, here's 6, we put a circle on it, it's everything but 6. So the domain for f is going to be minus infinity up to 6, union 6 all the way up to infinity. So that gives us the domain of f, but at the same time that gives us the range of f inverse. So this piece right here, it's the domain of f, and it is also the range of f inverse. Okay, so there's half the problem. We found the domain of f, and we also found the range of f inverse. So now let's find the range of f. But like we said a second ago, we can never find ranges. We can only find domains. So what we're going to do instead is find the domain of f inverse. So the domain of f inverse. So what is f inverse? We found that a second ago. That's 5 plus 6x over x minus 1. Again, so when we're finding domains, we just ask ourselves, are there square roots and are there fractions? Well, there's no square roots, but there are fractions, and the bottom of our fraction can never be 0. So x minus 1 is not allowed to be 0, which means x cannot be positive 1. So we go to our number line, here's 1, we put a circle on it, and then we shade to the right, and then we shade to the left. So in this situation, our domain for f inverse is going to be minus infinity all the way up to 1, and then 1 all the way up to infinity. Okay, so this is the domain of f inverse. But at the same time, the domain of f inverse is the same thing as the range of f. So this piece right here is also the range of f. And so now we have the 4 pieces that we need. So the problem asked us to find the domain and range of f. So here's the domain of f, here's the range of f, and it also asked us to find the domain and range of f inverse. So here's the domain of f inverse, and again here's the range of f inverse. And so that takes care of the second problem. The third problem, what we want to do is calculate this, log base 5 of 625. And when it's ever having you do these type of problems, it's going to happen to where this inside piece, the 625, is going to be able to be written as this base 5 to some number. That number. And so the first thing to do to solve this problem is figure out 5 to what number is 625. So if you have a calculator, say if you just do 5 to the second power. Well, that's 25, so that's not going to be right. Then you do 5 to the third power. Let's write these all down. So 5 to the second power, that's 25, so that's not the one we want. 5 to the third power, that's 125. That's not the one we want. 5 to the fourth power is 625. Sorry, 625. So 625, 5 to some number, that number is 4. 5 to the 4 is 625. And so what we're going to do is rewrite this problem as log base 5 of, instead of 625, we're going to write 5 to the 4. And so now we're going to use log rules. And the first log rules is this power can move into the front. So this is going to be 4 log base 5 of 5. And then remember, whenever the base and the inside are the same thing, so the base is 5, the inside is 5, that's just equal to 1. So this is 4 times 1, which is equal to 4. So the answer to this problem is just going to be 4. Okay, the next one. We want to simplify again, log base 6 of 6 to the 3. And so this one's easier than the last problem. This problem sort of starts right here at this step. So what we can do, the first thing to solve this one is, well, this 3 is a power. We can just move this 3 into the front. So it's going to be 3 log base 6 of 6. And now here the base and the inside are the same thing. They're both 6. So this piece is just going to be 1. So it's 3 times 1. But 3 times 1 is just 3. So then log base 6 of 6 to the 3 just simplifies to 3. Okay, our next one. So what we want to do for this problem is convert 16 to the 1/2 equals 4. So we want to turn this into a log equation. And in order to turn this into a log equation, we look at this problem and we look for the piece that has the exponent, which is this 16. And then once we do that, we're going to take the log of that base on both sides. So the log base 16 of both sides. So we're going to do the log base 16 of the left-hand side, 16 to the 1/2, equals the log base of 16 of the right-hand side. So log base 16 of 4. So log base 16 to the left, log base 16 of the right. Now in the previous problem, we see that this left-hand side can just be simplified to 1/2. So this 1/2 moves to the front, and all we have is log base 16 of 16, which is 1. So this left-hand side is really just 1/2 times 1, which is 1/2. And on the right-hand side, we don't do any simplifying. When we're converting to a log equation, you don't simplify this log on the other side. So this is going to be the log equation. 1/2 equals log base 16 of 4. So the next one, number 6, we want to do the same thing. We want to convert e to the 4 equals p. So we want to turn this into a log equation. So again, just like in the last problem, we look, okay, what is the thing that has the exponent? And that's this number e. So what we're going to do is take the log base e of both sides. So log base e of the left equals log base e of the right. And just like before, so this 4 can go into the front, and all we're left with is log base e of e, which is 1. So this left-hand side is just 4. And on the right, we just have log base e of p. And if we remember, another way to write log base e is natural log. So instead of writing log base e of p, we can just write natural log of p. And so this would be the log equation we're looking for this problem. Right, so the next problem. What we want to do is take this log equation, log base 2, 16 equals 4. And now we want to turn this into an exponential equation. Okay, so in order to turn log equations into exponential equations, we look at the base of our log. So the base of our log is 2. And then what we're going to do is we're going to raise both sides to the second power, meaning we're going to take this 2, so we're going to do 2 raised to the left, so 2 log base 2 of 16, and then 2 raised to the right, 2 to the 4. And then there's a log rule that we need to use here, that if we have, say, a to the log base a of x, this is equal to x. So whenever you have this number down here and the raised to a log and the base of the log is also that number, you just get rid of everything and you're only left with the inside. So here, this number down here and the base of the log are the same thing. They're both 2. So we can get rid of this 2 and get rid of this log, and we're just going to be left with the 16. So the left-hand side is 16, and the right-hand side we just leave as 2 to the 4. And so this will be what the converted exponential equation is that we want. So the next problem, number 8. So the same thing, we want to take the natural log of 75 equals 4.3175, and we want to turn this again into an exponential equation. So in the last problem that you saw, the first thing we did is we looked at the base of our log and we raised that to both sides. Here we have natural log, and natural log means the base is e. So if we see natural log, what we're going to do is we're going to take e and raise it to both sides. So natural log of 75 equals e to the 4.3175. And just like before, so here this number is e and the base of natural log is e. So this e and this natural log cancel each other out, and all we have is 75. So this left hand side just becomes 75, and the right hand side we just leave as e to the 4.3175. And this is going to be the exponential equation that we want. Okay, so this next problem, what we want to do is take log base b of p to the 4 q to the 6 over m to the 5 b to the 9, b to the 9. And then what we want to do is expand this as sums and differences of logs. So the first thing we're going to do this is, well, we see though in this problem here there's division going on. We have this thing on the top divided by this thing on the bottom. So the first thing, and if you remember, we can break up division with subtraction. So the first thing we can do is rewrite this as log base b of the thing on the top, so p to the 4 q to the 6, minus log base b, and then the piece on the bottom, m to the 5 b to the 9. All right, and now after we do that, we look at each of these pieces separately and see how can we simplify them. Well, in this first one right here, we have multiplication on the inside, p to the 4 times q to the 6, and we can break up multiplication with addition. So this left-hand side is going to become log base b p to the 4 plus log base b q to the 6. Now minus, and the same thing over here. We have this multiplication, so we're going to break it up with addition. So we're going to have log base b of m to the 5 plus log base b to the 9. And we need to put this piece we just did here in parentheses. So this log base b of m to the 5 b to the 9, it turns into this piece, and the whole thing needs the minus sign. Okay, so now let's do the next step. Well, here we have powers. Let's just work with these two first pieces. There's a power here and a power here, so we can just bring that power into the front. So this 4 is going to go in the front, so we'll have 4 log base b of p, plus the 6 is going to go in the front, we'll have 6 log base b of q, minus, now let's work with the inside piece. This 5 is going to go in the front, so we'll have 5 log base b of m, plus, so now this 9 is going to go in the front, 9, and we'll have log base b of b. And then the next step, we'll notice that, well, this log base b of b is just 1, so this piece right here is really just 9 times 1. Okay, so now the next step is to distribute this minus sign. So let's just rewrite these first two pieces. We'll have 4 log base b of p plus 6 log base b of q, and minus 5 log base b of m, and then minus 9. Again, this is minus 9 log base b of b, but the log base b of b is 1, so this is just 9 times 1, so this is really just minus times 9, so minus 9. And this is going to be our final answer. This is everything expanded as much as we can into sums and differences, so just got some sums here and then differences right here. How did I do this? 1 second. This is number 9, not number 8. Okay, so the next one, number 10. Okay, so we want to do the same thing with natural log 4 over 9x to the 9 times y on the bottom. So again, like before, we want to expand this into sum and differences. So the first step here is, well, we see we have division. There's this thing on the top divided by this thing on the bottom. So we're going to break that up with subtraction. So this is going to end up equaling natural log of 4 minus natural log of 9 x to the 9 times y. So now this natural log of 4, there's nothing we can do with that. So we're just going to rewrite it. Can't expand it or anything. It's as simplified as it can be. So we have this minus sign, but this piece right here, we have multiplication, 3 things multiplied on the inside. So we can break all that up with addition. So this is going to be natural log of 9 plus natural log of x to the 9 plus natural log of y. So we have these 3 pieces multiplied together, so we can break all of them up with addition. So the 9 goes in the first one, this x to the 9 goes in the second, this y goes into the third. So now what we can do is, so the only thing over here we can simplify is we can bring this 9 into the front. So we'll have natural log of 9, can't simplify that. This 9 moves into the front, so 9 natural log of x, and then plus natural log of y. And so now what we can do is distribute this minus sign. So we'll have natural log of 4 minus natural log of 9 minus 9 natural log of x minus natural log of y. Okay, so the next problem, number 11. What we want to do is work backwards from this last problem. We want to take 1/2 log of a plus 9 log of b, and then combine this into 1 log. So the first thing what we're going to do is to combine is we're going to take these powers that are in the front and bring them on the inside as exponents. So we're going to take this 1/2 and bring it on the inside as an exponent. So it's going to be log of a to the 1/2. Plus, and we're going to take this 9 and bring it inside as an exponent. Log of b to the 9. So remember, we can always take numbers in the front and bring them on the inside as exponents. So this 1/2 goes as a power. Now this 9 goes as a power. And now what we have is we have 2 logs adding together. And whenever that's the case, we can write 1 log symbol and then multiply the insides. So we'll take this inside, a to the 1/2, and multiply it by that inside, b to the 9. And now we combined everything up here, these 2 pieces, into 1 log. So this is going to be the answer that we're looking for. Okay, so this next problem, number 12. So we're given some information. We're given that log base b of 2 is roughly the same thing as 0.568. Log base b of 4 is roughly 1.136. And log base b of 6, log base b, oh, that's a 6. Log base b of 6 is 1.468. And then what we're asked to do is find log base b of 4 over b. So how we're going to do that is, the first thing we're going to do for this log base b of 4 over b, well, we're going to break this up using those log rules. So here we have division. We have log of, there's 4 divided by b on the inside. So what we can do is write this as log base b of 4 minus log base b of b. So remember, when you have division on the inside, you could break it up with subtraction. So the thing on the top goes in the first log and the thing on the bottom goes in the second log. And just simplifying this a little bit, well, we're given to us that log base b of 4 is 1.36. So this first number is 1.136. And minus, we'll look at the second number. We have log base b of b. So the base and the inside are the same thing. And whenever that's the case, it just equals 1. So this is going to be this piece right here comes from right here, and this is just going to be 1. And then if you subtract these 2 numbers together, you get 0.136. Okay, so this next one that we want to do, number 13, is we want to simplify 10 to the log of 4x minus 5. And we talked about this one in one of the previous examples. This is going to be coming from the rule that if we have a to the log base a of x, that just equals x. And that's what we have here. Remember when we have just the word log and we don't have a base written, that means that their base is 10. So really it's the same thing as log base 10. So here we have 10, log base 10. So like in this situation, we have a number raised to a log, but with the same number as the base, and then something on the inside. And whenever this happens, you can just cancel out this and this log up here, and you're just left with the inside piece, x. So our inside piece in this situation is 4x minus 5. So this just using this log rule over here, this piece is going to simplify into 4x minus 5. Okay, so our next problem, number 14. So what we want to do is we have this exponential equation, 2 to the 6x minus 3 is equal to 4. And then we want to solve this equation. So whenever we want to solve exponential equations that look like this, we have just a number on one side and a number on the other side, and that number on the other side has an exponent. In this situation, 6x minus 3. We're going to take that number that has the exponent, this 2, and we're going to do the log of that base on both sides. So the first step in this problem is we're going to take log base 2 of the left-hand side, 2 to the 6x minus 3, and that's going to set it equal to log base 2 of the right-hand side, log base 2 of 4. Okay, so now on this left-hand side, this 6x minus 3 is a power. It can just go into the front. So it's going to be 6x minus 3. And then what we're left with is log base 2 of 2, which is 1. So this left-hand side really is just 6x minus 3 times 1, which is 6x minus 3. So this left-hand side just simplifies only into this. Let's actually write all those steps out. So we take this power, move it to the front, and we're left with log base 2 of 2. And on the right-hand side, we can simplify this. So we can rewrite 4. So we said a second ago, whenever we have these problems, log base of a number, we want to rewrite this inside piece as the base raised to a number. But we know 4 is this base 2 raised to 2. So this right-hand side is log base 2 of 2 squared. Okay, well on this left-hand side, like we said a second ago, log base 2 of 2 is just 1. So this is just going to be 6x minus 3. And over here, this 2 can go into the front, and we're just left with log base 2 of 2, which is 1. So really all we have is this equation now to solve. And so what we can do is add this 3 over, so we get 6x is equal to 5. Divide by the 6, and we're going to get x is equal to 5 over 6. Okay, so in this next problem, number 15, so this is a similar but a little bit different of a setup. We have 15x equals 5 to the x plus 1. So in this situation, it's not like the previous one where something has an exponent and something doesn't. So in this problem, what we're going to do is take the log of both sides. There's two things we can do here. We can either, so any log that you want, you can take on both sides. So let's just say, let's take log base 5 on both sides. The base that we're going to choose is either going to be 15 or 5. It doesn't matter which one you choose here. So what we're going to do to solve this problem, let's just take the log base 5 of both sides. So we're going to do log base 5 of the left, 15x, is going to be log base 5 of the right, 5 to the x plus 1. So again, all we did is take log base 5 of the left equals log base 5 of this right-hand side. So now we're going to use log rules. So this x can move into the front, so we're going to have x times log base 5 of 15. So we can't really simplify this one right now. We're just going to leave it like this. Equals, so this x plus 1 can go into the front. And what we're left with is log base 5 of 5, which is 1. So this right-hand side simplifies into x plus 1 times 1. Same thing in this step up here. When we took the 6x minus 3 into the front, and we had this number, the 6x minus 3 times log base 2 of 2, but this piece right here was just 1, just like it is in this situation. Okay, and now, so we have this equation, and we want to solve this equation for x. So we want to get the x's on the same side and everything on the other side. So the first thing we want to do is just subtract this x over. So we're going to have x log base 5 of 15 minus x is equal to 1. Again, all we did here is to subtract this x over to the left. So now what we have right here is, well, x right here and x right here, so we can factor out an x. Let's do that up here. So we're going to factor out an x, and what we're left with is log base 5 of 15 minus 1 is equal to 1. So when we factor out the x from this left-hand side, you factored out an x from this piece and this piece. So if we multiply this x back through, we need to get this side. But we do. So x times log base 5 of 15 is this piece right here. X times minus 1 is that piece right here. And then still equals 1. And the last thing to do to solve for x is to divide this number onto the other side. So x is equal to 1 over log base 5 of 15 minus 1. Again, just dividing log base 5 of 15 minus 1 over to the right. So we have 1 divided by this number. So in this problem, though, you're going to need to use a calculator to figure this out. And so what we need to do is we'll figure out log base 5 of 15. So let's do that down here, just off to the side. So log base 5 of 15. So on your calculator, you can't just type in log of 15 because the base here is 5. And most calculators don't have, actually pretty much no calculator doesn't have a log with a base of 5 on it. So this is the calculator I have. So what you're going to, can you see that? Let's see, right here. So you see most calculators are going to have this button, either just a log button, which means base 10, or you're going to have this natural log button, which just means base E. So what we're going to want to do we either want to use either of these buttons, but we can't just use it directly because the base here is 5. So we want to do something called the change of base formula. So what we can say is log base 5 of 15, that's the same thing as just regular log of 15 divided by regular log of 5. So now what we can do in order to find this, and so the problem's also telling us to round to 3 decimal places, so we have to keep that in mind as well too. So we want to find, well, this equals this. So we're going to first find the log of 15. So you just type the log button, put it into 15, and we get this number right here. So we want our final answer to be rounded to 3 decimals. So while we're doing this side work, we're going to put down more than 3 decimals. So this is going to be 1.17609. And on the bottom, log 5. 0.69897. So now if we would divide these two numbers, so we can do 1.17609 divided by 0.69897, we get this, 1.6826. So then this piece right here, replacing log base 5 of 15 with this number. So this is going to be 1 over 1.6826 minus 1. And so we put that into a calculator. So how we could do that is we're going to have, so this top 1, then divided by, and then in parentheses we need to put this 1.682. So 1.6826 minus 1, close the parentheses, then we get this number. So this is going to equal, into 3 decimal places, it's going to be 1.46. And because we have a 4 here and then a 9 right here, this 9 will round up to 4, so this is going to be a 5. So 1.465. So on to the next one, number 16. So we want to solve this equation. Log of x plus log x plus 3 equal to 1. And in order to solve these log equations, what we want to do is combine all the logs and put them on one side, and then all the other just numbers just on the other side. So the first thing to do to combine these 2 logs is, well, we have 2 logs adding together, so we can just multiply the insides. So we can write 1 log and then do this, x times this, x plus 3. Then equals 1. And now what we can do in order to get rid of these logs, well, again, we just have the word log written here, and that means log base 10. And whenever we have these type of equations, to solve for x, we're going to take the base, which is in this situation is 10, and raise it to both sides. So we're going to have 10 to the log base 10 of x times x plus 3 equals 10 to the 1. And then using the log rules, this 10 and the log cancel each other out, and this left-hand side is this x times x plus 3. And then 10 to the 1 is this 10. And so now if we distribute this x, we're going to get x squared plus 3x is equal to 10. We subtract this 10 over to the left, x squared plus 3x minus 10 is equal to 0. Then we factor. So that's going to be x plus 5, x minus 2 is equal to 0. And then we solve both of these. This one gives us x is going to be minus 5. This one gives us x is equal to 2. But we need to check these answers. We have to remember that when we plug these answers back into the original problem, which is log of x plus 3 equal to 1, we can't get a negative on the inside of a log when we plug these numbers in. So you see, if we were going to plug in minus 5 here, we're going to get log of minus 5. So we can't have that. We can't have a negative on the inside of a log. So just because when we plug minus 5 into here for x, we get a minus 5. So for example, if we were going to plug in minus 5, we're going to get log of minus 5 plus log of minus 5 plus 3 equals to 1. But right here, we can't have a negative. So because there's a negative on the inside of the log, we have to get rid of that answer. But if we were to plug in 2, there'd just be a 2 here, and a 2 plus a 3, which is a 5 here, and then the 1. So no negatives on the inside of our log. So for this situation, x is 2 is going to be our only answer for this problem. Okay, so this next equation, we want to solve log of x plus 12 minus log of x plus 1 equals log of 7. So what we can do here is, let's keep this log of 7 on the right hand side, but we can combine these two logs on the left hand side. So there's subtraction, so we're going to combine these logs with division. So this left hand side is going to be log of this thing divided by this thing, so x plus 12, x plus 1 equals log of 7. Again, so we have subtraction here, so we're going to write one log and then divide these two things. So x plus 12 divided by x plus 1. And we have our equals, and then we have our log base 7. And then there's a log rule that if we have, say, log of something on the left equals log of something on the right, so of this form, log of x equal to log of y, then we can just get rid of these logs and just say x equals y. So in this situation, we can just get rid of this log, get rid of this log, and say that this piece is equal to this piece. So this tells us that x plus 12 over x plus 1 is equal to 7. And so now in order to solve this equation for x, we want to get rid of the fractions. So we want to multiply this whole problem by x plus 1. So multiplying x plus 1 on the left, that's going to get rid of this fraction. This is going to cancel, and we're just going to have x plus 12. And then we multiply it on to the right, we're going to have 7 times x plus 1. And now what we're going to be able to do is distribute the 7. So x plus 12 equals 7x plus 7. And get the x's on the same side, the numbers on the other side. Let's subtract the 7 over, subtract this x over. So the x's cancel on the left. We have 12 minus 7, which is 5. 7x minus x is 6x. These 7's cancel. And now to solve for x, all we have to do is just divide the 6 over. So we get 5 over 6 is equal to x. Okay, so 5 over 6 is equal to x. Okay, so problem number 18. We want to solve this system of equations. 5x plus y is equal to 2. 7x minus 3y is equal to minus 28. And we want to use any methods, substitution, elimination. So those are the methods that we can use. So for this one, it's always going to be easiest to use elimination in my opinion. And so the easiest variable to eliminate here is going to be these y's. So you see, if we multiply this whole entire top equation by a 3, there's going to be a positive 3 here and a minus 3 here. So if we added them together then the 3's are going to go away. So the first thing what we're going to do, the y's are going to go away. The first thing we're going to do is, in order to eliminate the y, so we're going to take this top equation, let's call this one equation 1. This is going to be equation 2. So we're going to take our equation 1 and multiply 3 by it. And doing that, so we're going to have 3 times 5, which is 15x, 3 times y, which is 3y, 3 times 2, which is 6. And now we're just going to take our equation 2 and just rewrite it again. So 7x minus 3y equal to minus 28. So now what we can do is add these two equations together. And doing that, we're going to cancel out the y, only giving us an x, so we can solve for x. So if we add these two equations together, we're going to get 15x plus 7x, which is 22x. 3y plus negative 3y, so that goes away. And 6 plus negative 28, which is minus 22. And now what we can do is just divide this 22 over to the right. And so the 22 is on the left cancel. And 22 over 22 is, well, minus 22 over 22 is 1. So we get x is equal to negative 1. So there's one of our answers. And once we find one of our answers, we can take this and just plug it into either one of these equations. So let's just plug it into equation 1. So we're going to take x equals minus 1 and put this into equation 1. And what that does for us is, so x is minus 1. So we're going to have 5 times minus 1 plus y is equal to 2. So that's minus 5. So we're going to have minus 5 plus y is equal to 2. Add this 5 over. We're going to get y is equal to 7. And so here's our x, here's our y. If the solution needs to be in an ordered pair, then it's going to be the point minus, it's going to be the point minus 1, comma 7. So here's our x, and then here's our y. Okay, so our next problem, which is a similar thing, we want to figure out x and y of this system of equations. 10x minus 8y is equal to 1. 5x minus 4y is equal to 3. So you see here, we can cancel out, so again, we want to use elimination. So how can we get the numbers in front of either x or y the same? Let's just choose x in this situation. Well, you see here, here's a 5 and here's a 10. If we just multiply this whole bottom equation by a 2, then we're going to get 10s in front of both of these x's. So just like before, here's equation 1, here's equation 2. Let's just rewrite equation 1. So we're going to have 10x minus 8y is equal to 1. And now let's take 2 and multiply it by equation 2. So we're going to have 2 times 5, so 10x. 2 times minus 4y, so minus 8y. And then 2 times 3, which is 6. But if you notice here, what goes on is that these are two of the same thing. So we have 10x minus 8y is 1. So let's write that down. We have 10x minus 8y is equal to 1. But at the same time, 10x minus 8y is equal to 6. So you see, 10x minus 8y is 1, but 10x minus 8y is also 6. So 10x minus 8y is 1, 10x minus 8y is also 6. But really what this tells us is that 6 is equal to 1. But this is not true. 6 is not the same thing as 1. And so whenever you get a situation like this tells us we have no solution. Okay, so our last problem, problem number 20. We have log base c of the 4th root of c. And whenever we're simplifying these types of log problems with these square root signs on the inside with a number right here, we want to use this rule that if we have, so the nth root of any number, nth root of x, we can rewrite that as x to the 1 over n power. So the first step of this, we'll have log of c. We're going to rewrite the 4th root of c as c to the 1/4 power. And then using log rules, this 1/4 is going to go into the front, so we'll have 1/4 log base c of c. But here the base and the inside are the same thing, so this is again just 1/4 times 1, which is equal to 1/4.